Okay, in this video, again, we're going to continue talking about absolute value inequalities. We're going to do a little bit more of a complicated question this time, but let's review our pieces here. If we have a less than in between an absolute value function and a linear function, graphically, less than means that the absolute value will be below the line. Okay? Less than equal to means absolute value is below or on the line. And that's very important. Greater than means absolute value is above the line. Greater than equal to means absolute value is above or on the line. So very important to review these notes here. Let's do an example. My next example is going to be this big long inequality. 3 times the absolute value of x plus 2 minus 4 is greater than or equal to 8. Let's talk graphically first. This piece, that's your absolute value. It's going to look V, like a V on the graph, and it's going to be typed into y1. This piece, that's your linear. It's going to be the constant on your graph, and that's going to be in y2. That's important to understand those two things, but here's the really important part for inequalities. Greater than or equal to. That means we're looking for when the absolute value is above or on the line. Above or on the line. So let's do this on the calculator first to graph it, and then we'll compare our answers algebraically to our solutions. Okay? So calculator. In the function for y1 is going to be your absolute value. So 3, math, number, enter for ABS, and then x plus 2. Outside the absolute value is going to be a minus 4. That's my absolute value. In the linear section, it's just going to be the constant of 8. Okay? And then we're going to graph these. So look at your graph. There goes your V. There goes your absolute value. And then there's your line. So you have your V and your line. Okay? But we're looking for when our absolute value is above or on the line, because we had greater than or equal to. So I'm going to play with my window just to show more of the above graph. I'm going to go back to window. I'm going to change my y-maxes just to be a little bit bigger than 10. Let's make it 20, and let's count by 4s. I think I changed the wrong one. Let's go back and check that out again. I changed it to 2 instead of 20, so let's change that back to a 20 here. Now let's go to graph. Much better picture, much better. So there's my V, there's my linear piece. We know from equations that right here, their intersection points are very important. So we care about when we're on the line. Intersection points are when you're on the line. But we also care about when the V is above. So that's going to be this section here and this section here. So 2 different sections, which means I'm going to have 2 separate pieces of one answer. Okay? Now it all starts with our intersections, just like with the equations. So let's do that part first real quick. Second trace, 5 for intersect. Move over here to your first intersection point by using your cursor. Mine takes a little while. Hit enter for your absolute value. Hit enter again for your line. Hit enter to guess. And we get this x value to be a -6. That's pretty important. I'm going to put it right there. Do the exact same thing for my right side intersection. Second trace. Intersect. Move my cursor all the way back over there. We're getting there. We're getting there. Close. There we go, a little bit closer. Hit enter for absolute value. Hit enter for your line. Hit enter for guess. And we get the x value to be 2 right here. Now, how does that help? Well, if you look and notice what's happening is this is going to go on for infinity. And in fact, it's going to go left. So it's going to go on for a negative infinity. Okay? So we're going to have negative infinity. We're above all the way from negative infinity until we get to negative 6, and that's when we get on the line. Well, infinity always has parentheses because it's not definite. You can never touch it. You can never include it. So it's going to be a parenthesis. But negative 6 in this case, because it's on the line and we want it on the line because we have an equal to, it's going to be a bracket. We're going to union that with the other side, the other piece. It starts at 2 and goes all the way over forever and ever in this direction, which we know is going to be a positive infinity. So it looks like that. We know infinity we can never include. It's not definite. So it's parenthesis. But my 2 is on the line. We want it on the line because we have an equal to. That has to be included. That has to be a bracket. So in this case, our answer graphically gave us negative infinity to negative 6 included, union with 2 included to positive infinity. Okay? Notice here, you had 2 red pieces shaded in up here. 2 separate but together pieces. We have 2 separate but united together answers. Let's prove this algebraically. So again, we want this exact function here to be solved algebraically. So we're going to take it to our next screen. Well, let's just come back. Let's erase. Remember, the first step is to isolate. We want to isolate. So we're going to add 4 to both sides. Divide by our coefficient of 3 to get our absolute value to be equal to 4, which is, again, that's the important part. You got to get here. And then you separate and you make your 2 equations. And I shouldn't have put equal to. That's not equal to. That's greater than or equal to. Very, very different. Now, separate this to make your 2 equations. X plus 2 greater than or equal to 4. X plus 2. Multiply that 4 by negative 1. Don't forget your rule that says when you multiply by negative, you change or flip your inequality from greater than to less than or equal to. Then solve. Subtract 2 to get x to be greater than or equal to 2. That's important. Multiply first. Then subtract 2 to get x to be less than or equal to a negative 6. That's important. Now, let's do what most teachers want you to do, which is going to put this on a number line so we can actually get an interval notation. Let's graph this on a number line. We've got negative 6. We've got 2. We'll stick a 0 in between somewhere. Let's do negative 6 first. Less than or equal to. That equal to means inclusion, so it's going to be a close point. Less than negative 6 is going to be to your left. Graphing greater than or equal to 2. Equal to means a close point. Greater than is going to be to your right. This looks a lot like what we just did graphically. I have 2 separate pieces. I'm going to take each piece and write an interval notation for it. This piece first. This left side arrow means negative infinity. This negative 6 is equal to, therefore it's a bracket. I'm going to union it with this right side, which starts at 2 and goes to positive infinity. Parenthesis around infinity, bracket around my included 2. Same answer, algebraically, graphically. Again, you choose the method you prefer. Either way, you get the same answer.